Unit 3 Test Review. This is the review for the second test for the second 6 weeks. This test will cover solving systems of equations, graphing, substitution, elimination, solving systems of inequalities, applications of systems of equations and inequalities, solving systems of equations with 3 variables by substitution, Gaussian elimination, row echelon, applications of systems with 3 variables and prior knowledge, solving absolute value equations, transformations, and domain and range. Make sure that you review your video notes and practices. The test questions are not limited to the questions you will find on this review. Part 1. Solving systems of inequalities. Number 1. Graph the system of inequalities. Find the vertices and find a solution in the feasible region. We have y is less than 5x minus 2, y is greater than x plus 2, and y is less than 10. We could go to desmos.com/calculator to graph this system. Once you get there, you'll graph your 3 inequalities. And this darkest region right here would be your feasible region. To find the vertices, we will want to zoom out, and we're going to click on the 3 points of the triangle. So we have 10, 12, 1, 3, and 10, 48. So we'll take a screenshot of that and put it on our review. For those of you that have printed out the worksheet, sketch a picture of the graph as you see it. Number 2. Graph the system of inequalities, find the vertices, and find a solution in the feasible region. So this is the same kind of thing. We'll graph these on Desmos, find the 3 points for your triangle. So while we're graphing it on Desmos, to get the less than equal to sign, first type the less than sign and then type the equal sign. So here is our feasible region, this triangle right here. And a point that could be in this looks like -5, would work. So from there, we'll take a screenshot of the graph and then paste it onto the page. Again, for those of you that are drawing this by hand, just sketch a graph. Shade in the triangle part, label your vertices, and here's a point that would be in the feasible region. Number 3. Write a system of inequalities that represents the following graph. So we'll take each of these linear lines, find the slope and the y-intercept, and then we'll make the equations. So let's look at the solid line first. So we'll find the y-intercept. It is 2, and our slope will take 2 lattice points. It goes up 1, left 1. So your slope is -1. So from there we know that y something -x plus 2. Now to find that something, we'll do the test point 0, 0. since it's not the shaded side of this solid line, it needs to be false here. So 0 is something to 2. To make this statement false, we would say 0 is greater than or equal to 2. So our first inequality is y is greater than or equal to negative x plus 2. Then we'll go to one of the dashed lines. Let's do this one. So this y-intercept's also plus 2. And our slope, rise over run, we're going to have down 3, left 1. So your slope is 3. So we have y is something to 3x plus 2. Now in this case, 0, 0 needs to be true, because if you shaded this whole side, 0, 0 would be on that side. So 0 is blank to 2. 0 is less than 2. So we'll put less than right here. Y is less than 3x plus 2. And then we'll do the last line. Our y-intercept for this one is negative 1. Find the slope of the 2 points. You get 1/3. So we have y is something to 1/3 x minus 1. Again, 0, 0 would be included here, because if you shaded this side with the solution, 0, 0 would be part of that. So 0 is something to negative 1. 0 is greater than negative 1. So this would be our system of 3 linear inequalities. Number 4, write a system of inequalities that represents the following graph. So our test point looks like we're going to do this one, and it will be 1, 1. And it needs to be true for all 3 inequalities. So let's do the dashed line, the dashed horizontal line first. Horizontal lines is y, and the shaded regions below that, so it's going to be less than 2. And we'll do our test point. 1 is less than 2. We'll plug in 1 for y. That's a true statement. Now let's do the positive slope. So we have y and then we'll find the y-intercept is negative 2. Then our slope is rise 2, run 1. So up 2, right 1. That means your slope is 2. 2x minus 2. 1 is something to 0. 1 is greater than. I got the 0 because I plugged in 1 for x. 2 times 1 is 2. 2 minus 2 is 0. And then, of course, this 1 is just the y value. So we'll put y is greater than 2x minus 2. That would be our second inequality. It's a solid line, so we'll have a line under it. And then for the last one, it looks like the same slope, except for it's the other way. So this would be negative 2x. And your y-intercept now is a positive 2. We'll plug in the point 1, 1 to make a true statement. So we have 1 is blank to negative 2 plus 2. That's also going to be greater than or equal to. So this would be your system of inequalities for this graph. Part 2. Systems of equations, inequalities, applications. Number 5. Two brothers went shopping at a back-to-school sale where all shirts were the same price and all shorts too. The younger brother spent $159 on 9 new shirts and 6 pairs of shorts. The older brother purchased 9 new shirts and 5 pairs of shorts and paid a total of $143. How much did each item cost? So we want to set up the system first. There's 2 brothers, so there's 2 equations here. We'll have the younger brother and we'll have the older brother. We'll let X represent shirts, and we'll let Y represent the shorts. So for the younger brother, it says it was a total of $159, and it was 9 new shirts, so it'd be 9 times X plus 6 pairs of shorts, 6Y. And that would equal the total price of $159. For the older brother, it was 9 new shirts, so 9X plus 5Y for 5 pairs of shorts. And that would be a total of $143. To find how much each item cost, I'd say one of the fastest ways to find this one is to use elimination. We'll just subtract the 2 equations to get equation 3. So we have Y equals 16. So that means that each pair of shorts costed $16. To find how much the shirts cost, plug this number back into one of the original equations. I'll just plug it back into the first one. So we have 9x plus 6 times 16 equals 159. So from there we have 9x plus 96 equals 159. You want to subtract 96 from each expression, both sides of the equation. From here we have 9x equals 63. And then from there you want to divide each term by 9. So x equals 7. So your solution is shirts cost $7 each and shorts cost $16 each. Number 6. An employee at a company that assembles chandeliers is packing boxes for shipping. In one box, he packed a total of 5 chandeliers, and it had a weight of 147 pounds. A small chandelier weighs 11 pounds, and a large one weighs 57 pounds. How many of each type of chandelier was in the box? So we want to set up our system first. We have a small chandelier and a large chandelier. So we'll let X equal the small chandelier and Y represent the large chandelier. So in this box we have 5 chandeliers. So that means that X plus Y would equal the total, 5. The total weight was 147 pounds. And the small chandeliers were 11 pounds each, so 11 times X. The large ones were 57 pounds each, so 57 times Y, and it equals 147. From here, you could use substitution to solve for this. We could solve for X, and we'll put X equals 5 minus Y. So wherever you see an X in this second equation, we'll plug in 5 minus Y instead. So we have 11 parentheses 5 minus Y close parentheses plus 57Y equals 147. Distribute the 11 into each term. From there, we'll combine like terms. Subtract 55 from each expression. And then from there, you would divide each term by 46. And so you get Y equals 2. So that means the large chandeliers, there are 2 of them. And we'll plug it back in to our original equation to get X. So we have X plus 2 equals 5. So that means that X equals 3. Because 3 plus 2 is 5. So that would be our solution. Number 7. Pilar is buying pizza and cookies for a party. Pizzas cost $9 each, and cookies cost $5 per pound. Pilar wants to spend no more than $50, but she needs at least 30 pizzas and at least 2 pounds of cookies. Write a system of inequalities that represents this situation. So we could call the pizzas P and the cookies C. So we know that pizzas is $9 each. So it'd be 9 times P. Cookies is $5 each. So it'd be 5 times C. she wants to spend no more than $50. So we'll have less than or equal to 50. So this would be our first inequality. The next one, it says she needs at least 3 pizzas. So that means that P has to be greater than or equal to 3. She needs at least 2 pounds of cookies. So it says at least C is greater than or equal to 2. So this would be your system of 3 inequalities to represent this situation. Part 3. Systems with 3 variables. Solved by Gaussian elimination. So the first thing we want to do is make sure they're all in standard form. X term first, then Y term, Z term, equals, and then the constant term. They're all in standard form already, so we're done with that. The next thing we want to do is name each equation. E1, E2, E3. Now what we want to do is choose 2 of the 3 choices here. E1 and E2, E1 and E3, or E2 and E3. So we have to choose 2 of these 3 combinations to eliminate a variable. For this example, we'll go ahead and choose the first combination and the last combination. Again, it doesn't matter if you choose this one or the middle one, as long as you choose at least 2 of these. I will get rid of the X first. So with E1 and E2, we will get E4. So we'll have something times E1 plus something times E2 equals E4. Let's figure out what that something is if we're eliminating X. So to eliminate X, we want these to cancel. So we could leave the E1 alone. So just multiply by 1. E2, we can multiply this by 4 to get them to cancel. Because 4x plus negative 4x is 0x, they're eliminated. So when you multiply an equation by a scalar, you need to multiply everything, both sides, even the constant on the other side. So we'll go ahead and write that out. So we have 1 times our first equation and then we have 4 times our second equation. From there, we'll distribute into all the terms and rewrite our 2 equations. So once we've written those out, we're going to combine the 2 equations. The x's become eliminated, they go away. We have 5y minus 14z equals negative 4. And we don't want to go any further with this equation yet. We'll just call it equation 4. And we'll put that off to the side for just a moment. Now we'll use E2 and E3 to also eliminate x. So we'll have blank E2 plus blank E3 will equal E5. So to get the x's to cancel here, we don't have to change anything. So we'll really just multiply these by 1. So we could go ahead and write out our two equations. They're just the same as what we had. And then from there, you want to combine the two rows. So this cancels, that's eliminated. We have negative 2y minus 2z equals negative 6. And that is our E5. From there, we want to have something times E4 plus something times E5 equals E6. Now it doesn't matter if you eliminate x or y or z. We've already eliminated x. Now we can either eliminate y or eliminate z. We'll go ahead and eliminate y here. So to eliminate y, we want these two to cancel, the 5y and the negative 2y. So we'll multiply the first equation by 2. Multiply the second equation by 5. So we'll go ahead and show those steps. So we have 2 parentheses the first equation here, E4, and then we have 5 parentheses the second equation here, E5. So we'll distribute the number into all the terms here, even the one on the other side of the equation. So after we've multiplied the two equations together, we'll combine like terms. These eliminate. We have negative 38z equals negative 38. Divide each term by negative 38. And then so z equals 1. So from there we'll substitute the z back into either E4 or E5. I'll put it at E5. So we have negative 2y minus 2 times 1 equals negative 6. We'll solve for y. We have negative 2y minus 2 equals negative 6. Add 2 to each expression, both sides of the equation. And then you get negative 2y equals negative 4. Divide each term by negative 2. You get y equals 2. So we'll plug both of these numbers back into one of the originals to solve for x. I'll put it in equation 2 since the x is already it's already by itself without a coefficient other than 1. So we have x plus 2 times 2 minus 5 times 1 equals negative 7. X plus 4 minus 5 equals negative 7. X minus 1 equals negative 7. Add 1 to each expression, both sides. X equals negative 6. So your solution here is the ordered triple, negative 6, comma, 2, comma, 1. Number 9. Solve by substitution. We have 3 equations, so we want to name the 3 equations. E1, E2, E3. What you want to do for substitution is solve for a variable and then plug it into another equation. So let's go ahead and solve for z in equation 2. So we want to isolate z, so we'll move everything to the other side. We have z equals negative 2x plus y plus 18. And we just subtracted 2x to the other side. We added 1y to the other side. And we'll go ahead and solve for y in the first equation. So we have negative 2x plus 3y equals negative 28. Add 2x to each expression, both sides. We have 3y equals 2x minus 28. To get the y by itself, we divide each term by 3. So we have y equals 2/3 x minus 28/3. So from there, wherever we see a z in the third equation, we'll plug in this expression, and wherever we see a y, we'll plug in this expression. So we have negative 5x minus 5 parentheses 2/3 x minus 28/3 minus 2 parentheses 2 x plus 2/3 x minus 28 all over 3 plus 18. close parentheses, equals 1. And you would solve this equation. Distribute these. And then if you distribute them, you get this. Combine the like terms. So then you get negative 9x plus 46 equals 1. Subtract 46. You get negative 9x equals negative 45. Divide each term by negative 9. And then you get x equals 5. And then we'll plug it back into equation 1 to find y. So negative 10 plus 3y equals negative 28. Add 10. You get negative 18 equals 3y. Divide each term by 3. You get y equals negative 6. You'll just plug in the x and the y into either equation 2 or equation 3 to find z. Let's put in equation 2. So we multiply this out, we get 10 plus 6 plus z equals 18. So that's 16 plus z equals 18. Z equals 2. So your solution is the ordered triple 5, negative 6, 2. Number 10. Determine whether the following ordered triplets are a solution to the system. So we'll plug this into all 3 equations and see if it's a true statement or not for each. If it's not true for all 3, then it's not the solution. So we'll evaluate each of these and see if they're true or false. So for this first one, we have 9 equals 9. That's true. Okay, we'll do the next equation. We have negative 8 equals negative 8. That is also true. And so we'll go to the last equation. We have 13 equals 13. And that's also true. So that means this is a solution. And then we'll try it for the second point. So we'll plug in the numbers for each of the 3 equations and see if they're true or not. So we'll go ahead and evaluate these. So on this one we have 3 minus 1, that's 2. 2 equals 9. That's false. So because that first was false already, we can automatically say this is not a solution. Number 11. Write an augmented matrix that represents the system of equations. So the first thing to do first is to make sure they're all in standard form. X, Y, Z equals constant. So we're going to have 3 rows and 4 columns. We'll write the coefficients as the elements. And then we have 1, 1, negative 2, and then negative 8. And then for the last row we have negative 1, negative 2, 3, and 13. So this is our augmented matrix. Now for the next one, these are not in order yet. So we need to put these in order first. So we have 0x plus y plus z equals 11. We have 2x plus y minus 2z equals 4. And then we have negative x minus 4y plus z equals 1. We want to move the y term and the z term to the other side. Notice I put a placeholder here because there's no x. So then we'll write our matrix. Our augmented matrix will be 0, 1, 1, 11, then 2, 1, negative 2, 4, and then negative 1, negative 4, 1, and 1. Annette, Barb, and Carlita work at a clothing shop. One day, the 3 had combined sales of $1,480. Annette sold $120 more than Barb and Carlita combined sold $280 more than Annette. How much did each person sell? So first we want to define our variables. Let's say Annette is A, Barb is B, and Carlita is C. So it says all 3 of them together had $1,480. So I have A plus B plus C equals $1,480. It says Annette sold $120 more than Barb. So for that we could have A equals B plus $120. And then Barb and Carlita together, so it'd be B plus C, equals $280 more than Annette. From here, we want to put it in standard form and set up a matrix. So let's do 1A plus 1B plus 1C equals the $1,480. 1A minus 1B plus 0C equals 120. And then you have negative 1A plus 1B plus 1C equals 280. So to write this as a matrix, we'll have 1, 1, 1, 1,480, and then 1, -1, 0, 120, and then -1, 1, 1, and 280. From there, we can put it into the Desmos calculator. So we go to desmos.com/matrix. From there, we'll click New Matrix, and we'll set up our matrix. It has 3 rows, 4 columns. Put in the elements. And then we'll put it into reduced row echelon form. So press RREF and then A. There's your solutions. We have 600, 480, and 400. That's your A, that's your B, and that's your C. And so that would be our answer. So Annette sold $600, Barb sold $480, and Carlita sold $400 worth of clothes. Part 4, Prior Knowledge. Number 13. A food manufacturer specifies that every family-sized box of cereal should have a net weight of 25 ounces with a tolerance of 1.2 ounces. Write the absolute value inequality that describes the acceptable net weights for the cereal in a family-sized box. So we want the form absolute value of x minus b is less than or equal to t, where b is the ideal amount and t is the tolerance. It could also say average, normal, actual, midpoint. And so from there, we'll identify what that ideal amount is. So it would be 25. And then the tolerance would be 1.2. Now the reason why the inequality sign is less than for the absolute value part is because on the inside of the number line, it would be this part. If it was on the outside, the outer parts, it would be faced the other way. It would be shaded on the outside. So our formula would be absolute value of x minus 25, close absolute value, is less than equal to 1.2. Number 14. Write absolute value equation with the following solutions. H equals -4 and H equals 10. What we want to do first is just make a number line. From there, we want to write -4 and 10. we want to have the form absolute value of x minus b is equal to t. B is going to be the midpoint between the two endpoints. And t is the amount it takes between b and one of the endpoints. So we'll go ahead and find the midpoint here. So 10 plus -4 divided by 2 to find the average, to find the midpoint. Equals 3. So b equals 3. 3 to 10 is 7. So t equals 7. So your formula would be the absolute value of x minus 3 equals 7. Okay, let's look at this one. Number 15. Solve absolute value of 4x plus 6 equals 2x minus 4. So the first thing we want to do is make sure the absolute value is isolated on one side. It is. From here we'll have our positive part and our negative part. So for the positive part, we just take off the absolute value sign and change them into parentheses. We just have 4x plus 6 equals 2x minus 4. That's the positive part. Now for the negative part, we have to put those parentheses back on there. We have negative parentheses 4x plus 6 equals 2x minus 4. So we'll solve for the positive part for x. Subtract 2x from both sides. Subtract 6, divide by 2, you get x equals -5. And then we'll do the negative part. Distribute the negative into each term. And then subtract 2x. Add 6. You get -6x equals 2. Divide by -6. And then you get x equals -1/3. From there, we'll plug it back into the original, see if it's a true or false statement for each. So we'll have 4 times -5 plus 6 equals 2 times -5 minus 4. So from this right here, we can see that this is going to be -14. An absolute value cannot equal a negative number, so -5 is extraneous. We'll do the same thing for -1/3. So we'll plug it in. So on this one we have negative 14 over 3. That's negative. You can't have a negative with an absolute value. That's also extraneous. So for this one, there's no real solution, and you have these two extraneous solutions. Number 16, describe all transformations. And we're talking about the parent function f of x. So the first thing it looks like it happened is a vertical, or the very first thing is this negative sign. That means that it reflects across the x-axis. The second thing, the 2/5, that means it's a vertical compression. Now, this 4 outside the parentheses, but it's on the inside of the other parentheses, is a horizontal compression. The negative 2 on the very inside is going to the right 2. And then the plus 4 on the outside is up 4. Now for this one it says find the characteristics of the graph. We have an absolute value graph. Our x-intercept is 2, 0. It's where it crosses or touches the x-axis. The y-intercept is where it crosses the y-axis. It's at 0, 4. The vertex is either the lowest point or the highest point. It's the turning point, that sharp point in the graph. That is also 2, 0 in this case. The axis of symmetry is that line that goes through the vertex. And that line is at x equals 2. In interval notation, the domain is negative infinity to positive infinity. And then the range is going to be y is greater than or equal to 2. In interval notation, we'll put, or y is greater than or equal to 0. So I'll put 0, infinity.